Welcome class 9. Today we are going to learn factors affecting the speed of sound in a gas. We all know that every object is made up of molecules, and also gas are also made up of molecules. So when there is heat applied to those molecules, they exhibit random motion. So when the temperature is increased, the kinetic energy of the molecules also increases, and since the kinetic energy of the particles increases, and also we know that the sound is also the vibration of the particles. So here the kinetic energy is connected with the vibration of the particles, as vibration means it's also a kinetic energy of the molecules or particles. So if the kinetic energy increases, then the speed of sound also increases. Thus we can say that temperature increases, then the speed of sound in the medium increases. Or if the temperature decreases, then the kinetic energy decreases. Thus the speed of sound also decreases. Thus we can say the speed of sound increases with the increase in the temperature of the gas. We need to note that the speed of sound in air increases by about 61 centimeter per second for each degree rise in temperature. Next, as the temperature of a gas increases, then its volume also increases. Okay, everything increases or expands when heat is applied, isn't it? So volume increases. So when volume increases, the density decreases. So we can say that temperature increases, then the density decreases. Also, we just now learned that if the temperature is increased, then the speed of sound also increases. This means that if the density is decreased, then the temperature is increased. That means the speed of sound increases. So with the decrease of density, speed of sound increases, and with the increase of density, the speed of sound decreases. So we can see that they are inversely proportional to each other. So the speed of sound is inversely proportional to the density of gas. Humidity. Humidity means increase of moisture in air. So when water molecules increases in air, there will be decrease in the density of air. So if there is if the density of the air decreases, then we know that the speed of sound increases. That means if density is decreased, that means the humidity needs to increase. So if the humidity increases, density decreases, therefore the speed of sound increases. So over here, humidity and speed of sound are related. They are directly proportional. So the speed of sound in air increases with the increase in humidity in air. Next, if the stream is flowing in this direction, then the boat, if it is traveling in the same direction, that is the downstream, then we know that the speed of the boat will be increased. Okay, and if just the opposite happens, if this is the flow of the stream in this direction, and if the boat needs to go in upstream, that is in the opposite direction, then the speed of the boat decreases. We all know that, right? Similarly, if wind flows in this direction and the sound is also propagated in the same direction, then the speed of sound will increase. Okay, and if the wind flows in this direction but the sound is propagated in the opposite direction, then in this case the speed of sound will decrease. Thus we can say that the speed of sound increases if it propagates in the direction in which the wind blows, and the speed of sound decreases if it propagates in the direction opposite to the direction in which the wind blows. So these are the four factors in which the speed of sound depend. Okay, so quickly we can see that the factors affecting the speed of sound in gas are: number one, the temperature of the gas. As the temperature increases, then the speed of the sound also increases. Next, number two is the density of the gas. If the density increases, then the speed of sound decreases. Or if the density of the gas decreases, then the speed of sound increases. Next is humidity. More the humidity in air, more will be the speed of sound. And lastly, the direction of wind. Wherever is the direction of the wind, whichever direction the wind blows, in the same direction the speed of light the speed of sound will be more. And in the opposite direction, opposite to the direction of the wind, the sound propagation, the speed of sound will be decreased. So with this we come to an end of our video. The assignment is to prepare notes for the topic discussed. Thank you.